have that. I have an update on your course evaluations. Would you like to know the grand total so far? We are at 7 out of 9. We need one more. I know. The other class has hit their goal of 26 out of 29, so we just need one more. And my apologies for the confusion about Qualtrics. And yes, Mackenzie tried to tell me, and I did not understand that you had gotten another survey. I thought it was just like the header, the email message had like somehow gotten to be the wrong message. But then I looked at the list and it was like, okay, you guys got both surveys by accident. So I'm still not sure how that happened, but I screwed it up. And if you accidentally completed the longitudinal survey, that's fine. It asked you about proportions of readings that you did and a few other things that are sort of not relevant for this class, but otherwise the questions are pretty much the same. So the class that UTA is 6 out of 25. Yeah, see, that's what I'm hoping to avoid, because regardless of your methodology, you want to have a representative sample to go from, right? Because the 9 of you are my population this semester. So hearing from as many of you as possible is going to be a useful thing. All right, so I'm looking at my list of things. I have web pages open to remind myself. I just realized that the links for the lecture 7 and example 7 were dead. They were from last semester and I hadn't updated them, so I fixed that right before class. I don't think we'll get very far into either of them, if at all, but I wanted to make sure that those are available. I did go ahead and post on today's class the videos that I recorded offline last fall, because we didn't get to any of that material, so that you'll have those for posterity as well. Homework 6 is out and folks are working on it. Does anyone want to throw any questions about homework 6? No? Well, you have until the end of finals week, 5 o'clock on next Friday. And just to remind you, next week we have no classes because it is finals week, but I am going to sit in front of my Zoom during the time I would have normally been teaching. So 12:30 to 4:45 on Tuesdays and Thursdays, you can find me here if you do want to ask any last minute questions or just come hang out and work. There's a lot of folks who like to do that. So that sounds good. Let's see. Any other logistical things that you want to ask about? No, we're good. Okay. Then let's see. Let's go back to what we were talking about last time. So, what do you remember from last time?
I remember I did most of the FA incorrectly, but since then I learned how to I was reminded on how to properly factor the things out. So that was good.
That's good. Yeah, the rule for trying to figure out how the model tells you what a slope is going to be for any predictor is to grab all of the terms that have that slope in it and then factor out the variable for which you want the slope. And whatever is left, the linear combination, is how you get your predicted slope from the model. So we looked at a couple more examples of that. That's good. What else? What kinds of research questions do interaction terms address? Let's go more big picture. Like, when would you need to do this in life?
If your predictors affect different people differently?
Yeah. So the general idea is, well, does this predictor matter in predicting this outcome? If the answer is, well, it depends, then that type of conditionality is addressed by these sorts of analyses are known as moderation analyses. And the type of interaction terms that we're studying are one particular form of moderation where it's a linear effect, meaning that a 1 unit increase in the moderator has the same effect on the slope. You can certainly have nonlinear effects in other forms as well, but yeah, in general, the idea that it depends. So this shows up a lot in intervention research. So if I have a control group and a treatment group, then I want to show that the treatment group improves more over time. That would be an interaction of occasion with group to be able to answer that kind of question. Does anyone have ideas from their world that they can think of? Questions about moderation like that?
So is this the thing where it's like more positive, less positive, less negative? Oh, yeah. So definitely in terms of like using like your communication device, how much difference does it make? Or, you know, if you withhold attention, you know, what effect does that have on behavior? So yes, I can definitely see that showing up in my line of research.
Good. So, as an example from my previous life, I helped a graduate student with her dissertation back when I was a graduate student, and she was examining the extent to which, let me say this correctly, she was studying psoriasis as a skin condition that is susceptible to stress and other kinds of environmental influences. And she was looking at the role of coping strategies in predicting psoriasis. And her hypothesis is that people who had better coping strategies had less of a reaction to stress as indicated by their skin condition. So if you wanted to know if stress was less harmful to people with better coping strategies, how would I set up a model to answer that question?
I'm thinking of having like a low or few coping strategies, medium amount of coping strategies, and then a lot of coping strategies, some sort of scale or measure of that.
It could be a grouping type of variable, as you indicated, or it could be a measured scale where it's a more continuous version of coping. Let me start typing. I'm going to pull up a Word document and we'll type down our ideas. And that means I need to do screen share. 1 second. So we would have, okay, can you all see this as a blank screen here? Good, all right. Let me move this thingy out of the way, as usual. So we would have something like, by the way, did I teach you how to write notation in a Word document this semester? I didn't. Do you want to learn? Yes, big nods. Okay. I'm redeeming myself from my earlier transgressions. So I am hitting the Alt and equal sign simultaneously, and that pops up the equation editor. So inside Word, PowerPoint, and like other Office-related products like that, there's an equation editor that's available from the menu, and there's a bunch of keyboard shortcuts you can use with it. So it says type equation here. No, really, I'd like to type an equation here. Now my computer's mad at me. That's what happens when you get too many things here at the same time. Do it again. Okay, so I'm typing inside here. So if I want to say that I have my outcome is y, and I want to give it a subscript. If you type shift and the underline key, which is to the left of the equals, and then whatever character you want to have a subscript, after you're done typing that, if you hit the spacebar, it becomes a subscript. Likewise, if I wanted to have a superscript like x squared, I can type that with that caret looking thing with a 2, and it becomes x squared like that. So you don't have to hunt and peck for the superscripts and subscripts inside the notation. So let's say here that we have our outcome is going to be y is going to be psoriasis severity as an outcome. So more is worse. And then we have hang on, let's go back into there 1 second. So we also have coping as another variable in the model here. Come on. Coping. We'll say that's going to be x. Let's call that x1 equals coping skill. So more is better. I'm going to call this predictor more generally. And the other predictor in the story is going to be stress. Okay. So those are the three variables in the story. If I want to build a model to answer the question, is stress less related to psoriasis severity in people who have better coping skills? What would that model then look like? I would have something like y equals what? What comes first?
Beta 1 x1, beta naught,
Beta
0.
Yep, beta naught or beta 0. So here's another trick. If I want to go find a beta, I can go up to the equation editor and hunt for it. So there's all these special characters and symbols and whatnot. Or I can use the same commands that people use in LaTeX, which is a program that people use to write equations and stuff. And no, I don't use it. I just know some of the keyboard shortcuts. So watch this. I'm hitting a slash. Is it that slash or this one? I can never do it. I do it so fast that I can't remember which one it is. I think it's this one. Yep, nope, wrong one. That's a different keyboard shortcut. So I'm going to hit the slash that's above the enter key, and then the letter that I want, and then I hit spacebar, and it becomes the Greek letter. I know, right? Blowing your mind. So then if I want an beta 0, I do the what is this, underline key? What is that thing called?
Underscore?
Underscore, thank you. I had it right before. And a 0. I got beta 0. Do I need an I here? Nope, because beta 0 is a constant. Now what do I need?
Severity?
Severity is already in here as my outcome.
Oh. Coping skill.
I do need coping skills, but what do I put in front of it?
Beta 1
beta
x1
1.
I.
Yeah, I did. Beta 1 with no I. And then I'll put in here, let's write x1 out so that we have less working memory. Coping. Coping does get an I because that's a variable. What comes next?
Beta 2 stress, or x2 I.
Yeah, beta 2 stress I. Anything next? Are we done?
Residual or error term.
We do need a residual. Anything else, or are we done? Remember, the research question is whether people who are have better coping skills have less of an impact of stress on their psoriasis severity.
Interaction.
Yeah. So for the sake of clarity, I'm actually just going to type severity over here too. So I need a third slope, beta 3. And then we have coping I times stress I. Okay. Now the tricky part. In order for the hypothesis to be supported in the direction that's anticipated, what do the signs need to be? So in this outcome, if I have a measure of severity, more is worse. So do you think that coping has an effect on severity? Which way
Negative
does,
effect?
yeah, we have a 1 vote for negative. That makes sense. More coping less severity. So coping is good for you. So I'll put a negative. Nope. It tried to make it plus or minus. Here, let me put some spaces in there. That'll work. How about stress? Yeah, positive. More stress, more severity. Stress is bad for you in this context. Now, is this going to be positive or negative? If coping makes the effect of stress weaker. Negative. Yeah. No. Now I'm learning keyboard shortcuts I didn't even know. So yeah, this is the hypothesized pattern of moderation. And this is the part that I often see people punt on in results sections. They say, I hypothesized moderation and the interaction was significant, so I have moderation, yay me. It's like, well, but what's the pattern? Did it turn out the way that you thought it would? So this pattern would be consistent with the idea that the relationship between stress and severity is less positive or weakened in people with stronger coping skills. All right. Questions?
What was the initial keyboard shortcut to get to the equation thing?
Alt equals. Or you can just go up here and type insert new equation. Stuff up here that I use that I don't know how to do on my keyboard, for instance, the accents. This is where you get like a Y hat or a Y bar, things that go on top of that. I don't know how to do that on the keyboard, although I'm sure there is a way. Okay, so how would this story have to change if rather than coping being a continuous variable that's measured in a quantitative fashion, we had people who were designated as low, medium, or high copers? Could I do that? Sure I can. I can do anything I want. The model is your oyster. Well, how would this equation have to change in order to accommodate that structure? So I'm going to go back to the betas for just a minute here. This is Control Z, by the way, to undo. There's another keyboard shortcut not everybody has seen before, but that's one of the ones I use most often. So how would this equation have to change, do you think, if instead of having coping as a quantitative moderator, we have it as a grouping variable of low, medium, or high? What would I have to do to this part?
Maybe center it to something?
Well, this would already have been centered. I didn't write that part, but I would have done something like this so that it's coping where 0 is somewhere inside the range of the data. But you're on the right track. How do I represent groups and group membership as a predictor variable?
Would you add like additional, I don't know how to say this exactly, but would you add additional parentheses?
Additional parentheses or additional variables in the parentheses?
That's what I meant.
You do know how to say it then. That's what you meant. So yeah, so if I had, for instance, 3 groups of coping, I might have something like, hey, stop that. Coping low versus medium. And then that would be coded, if I want the, let's say if I want the medium group as my reference group. I could do that, right? Let's make the low group the reference group. We'll do low first. If I had the low group, this variable would be coded like that across the 3 groups. And if I had coping low versus high, then it would be coded like that across the 3 groups. Alternatively, if I wanted to have medium versus high as the second contrast, I can switch that one to Actually, hang on. That's how I did it in the first place. There we go. That one to... Yep, I was already thinking along those lines. That's what it would be. Low versus medium is the first contrast, and then medium versus high would be the second one. And so then those variables would need to go into my typing. So I have one there, and I have one here. So I need to start over my beta count. I'll make that one 2, make that one 3. I'm going to return the line so we can see the whole thing here. Do I need to do anything else? If I want to test the same idea, that the effective stress varies as a function of coping, but coping is measured as a grouping variable, do I need to do anything else?
Is this where do you need to factor out?
I need to factor in, I would say, because this is no longer adequate to describe the effect of coping.
Okay.
So I got to add terms.
So now we have a coping low versus mid and a coping mid versus high.
Yeah, if I can type correctly. Low versus M times stress. And medium versus high. Indeed.
Is the bottom line beta 3? Is
Yep.
that beta? Why is that beta 3?
Because I hadn't fixed it yet.
Okay, I thought there were some higher level things going on.
Nope, just a regular old-fashioned typo. Yeah, you can only have one beta 3. So yeah, then in order to answer the question about whether coping changes the relationship between stress and severity, that question requires two slopes to work together to answer it. So in the same way that we would have these two slopes that distinguish the three coping groups as a main effect, beta 1 and beta 2, we would have these two interaction slopes to distinguish the effects of coping as a moderator of the stress-severity relationship. What if stress was also categorical? What if stress was also low, medium, high?
So
And
add
this
two
would-
more betas. I'm sorry, Jerome, go ahead.
Oh no, you got it.
Yeah, but you guys can't see each other when I screen share. I always forget about that until I'm in a meeting where someone's screen sharing, and then we all talk over each other because we can't see the visual cues that someone's getting ready to talk. So, but thank you for participating despite this bizarre environment. Yeah, we need two of those. And so if I add two of these stresses here, then that translates into 2 here and 2 here. So that would actually be a total of 4 interaction terms.
Lisa, does that mean you just would add them into the betas that are already there? You wouldn't like create more, like you wouldn't necessarily have to create even more betas since they're like new variables, like that you would just add them to what's there. Like
I'd swap this one out for one of the new dummy codes. I would have to add another one to go with it, which would then, this would become beta 5 and beta 6. And then
Okay.
I'd also have to have swap this one out for one of the dummy codes, and then add another set.
Okay. So you would have to add more to encompass all of them. Okay.
And so this is the linear model representation then at that point. Do you want me to write it out? Would that be helpful to see it? Okay, we will do that real quick then. So in the same way that we're going to add this to the story of how to make the variables, we'll have stress low versus medium, and stress medium versus high. So then that means that one goes here. I'm actually going to return these so that we can keep the lines from going crazy. Come on over. So there's that. Now I need another one. And then this one is medium versus high. And so then this one is up to 5. This one is up to 6. And so then I would change that one to that. That one to that. Trying to get them aligned so that you can see the pattern a little more easily. That's a little better. Move that one over. So 5, 6, we're up to 7, 8. And then this one would be M versus H. I think I've got them all. Let me know if I'm mistyping. There. How's that? Question, if we keep adding interaction terms, we also may need to add a 3/line continuer or come up with some shorter names. Indeed. Indeed you would. So this representation then, where we have two different categorical predictors and we have all possible interactions among their dummy codes, this is the linear model representation of what would traditionally be called a two-way ANOVA. So this is not something that I ever saw when I was in ANOVA classes, and so I really didn't understand the complexity of the model that was being fit. But like if you tell SPSS, for instance, to add fixed factors to as categorical predictors in the model, and it will estimate all possible interaction terms for you like this. So there's additional complexity when you're dealing with categorical variables because then you have to have interactions and main effects of all the respective dummy codes, but it's the exact same concept. So what I thought we could do today, after finishing the age by grip strength regions of significance thing, is look at an example of something like this using the same data so that you get a little bit of exposure to this, and then what you could watch on your own if you are so inclined is a much more efficient way in terms of code to get to this same place. Okay, so staring at this here, does this make sense, the idea that every time you add a dummy code to the model to represent a predictor, you got to represent it all the way through the model if you're going to have interaction terms? The same would be true if we had nonlinear terms. So if I had, for instance, coping and coping squared, each of those could potentially interact with stress as a categorical variable or as a quantitative variable, your choice. And potentially if you had other predictors in the model, you could have higher order interaction terms. So 3-way interaction terms, for instance, 4-way interaction terms. It's ugly but doable. It just depends on the extent to which those terms would be sufficiently powered, because it takes a lot more people to detect higher order interactions, as well as reasonably expected, I would say. All right. Do you want to go back to the example? Finish up example 6? Does that work? Yeah. I have 2 versions of example 6 pulled up. We were on a model that included age by grip strength as an interaction term, and we were working through the interpretation of what that interaction term does. So this is page 12 of example 6. So there's only one interaction term in this model. The previous interaction terms between gender and age and gender and grip have been removed because they were not significant, and so there's only age by grip left over. So as a consequence, the age and grip strength slopes are both conditional on the 0 value of their interacting predictor, and the interaction term talks about what happens to each of those slopes for a unit increase in the other variable. So if I start with the age slope, that is a negative slope of age, conditional on somebody with grip strength equals 9. For every additional pound of grip strength, that age slope becomes less negative by 0.12. So the age slope is weaker in stronger people. That's the way I would talk about that. Age matters less in stronger people. And so then we went down to the estimate statements that I had requested to get a better sense of that interaction term. So this process of putting in prototypical values of the moderator variable at which to estimate the slope of the predictor is known as getting simple slopes or probing the interaction term. And it's a way to make it a little bit easier to tell what's happening. So the middle value here is what was given to us directly by the model. The age slope when grip equals 9 is the definition of the slope because grip strength was centered at 9. The grip strength, at 12 grip strength, the age slope is much less positive, or excuse me, is much less negative. It's actually turned into positive. And at a lower value of grip strength, it's much more negative. So this is where we left off last time, is looking at the p-values that correspond to these things. For somebody who is at -1 standard deviation on the moderator of grip strength, for somebody who can squeeze 6 pounds, the age slope is significantly negative. For somebody who can squeeze 9 pounds, the age slope is still significantly negative, but it's weaker. And by the time we get to 12 pounds of grip strength, the age slope is not different than 0 and is actually heading in a positive direction. So somewhere between grip strength of 9 and grip strength of 12 is the point where the age slope stops being significantly negative. Okay, with me so far? So if we look at that in a picture, this picture, so the blue line is describing the age slope for somebody with 6 pounds of grip strength. That's significantly negative. The red line is also still significantly negative. That's somebody who has a grip strength of 9. But somewhere between the red line and the green line is where the line stops being significantly negative. The fact that this interaction term is linearly being moderated, so a 1 unit change in the moderator has the same increment to the slope all the way across the variable. What would happen if I kept going? What would happen if I plotted an age slope for somebody with 15 pounds of grip strength, 18 pounds of grip strength? What would happen if I kept going up? What kind of age slope would I have? Yeah, it would eventually become positive. So as you go down the moderator, the age slope is more negative. At some point it becomes 0, and as you go up the moderator, the age slope would eventually become positive. So rather than just artificially poking this interaction term at prototypical values of the moderator, an alternative strategy for moderation by quantitative variables is to figure out at what point the predictor slope is negative, is 0, and is positive. And that's what's known as regions of significance. It's an old procedure that has sort of not recently, but relatively recently come back. And I think it's useful in these particular contexts. So the rest of the handout is showing you how you would get the necessary ingredients to compute regions of significance. And I wrote a SAS macro program that does it. I also made an Excel sheet that does it. So it requires the standard errors of your predictors and moderators, but it also requires the covariance between the standard errors, which is something that doesn't show up by default in your output. So there's an extra piece of output that you have to ask for to be able to do this. And in Stata, it's given to you in the same regress procedure. It's just this extra option right here, SStat VCE. That prints an additional matrix that has the standard errors squared for your fixed effects on the diagonal and the covariances among your standard errors on the off diagonals. It's not available in ProcGLM and SAS, but it is available in something called ProcMixed, which is a procedure that allows you to estimate multi-level models in addition to single-level models. And so there's an option code B that I added on here. Otherwise, the syntax looks pretty much the same as it would in ProcGLM. You just get this additional piece of output. So the extra matrix that it shows up that is needed is right here. This is not something that you've seen before, and it's probably not something that you would ever see in practice. But the idea is that what each fixed effect could be is going to be related across the fixed effects. So this matrix captures those relationships among the standard errors. So I plugged it into my regions macro that I wrote here. A macro program is just a little piece of code that takes input in the form of saved SAS datasets from your output and does manipulations on them and spits out answers. And so it came up with the boundary values for when the age slope is going to be positive, negative, or 0. So the boundaries that this came up with is approximately, let's see, this is the other one. Let's go the other way, age by grip. It's 9 pounds and 18 pounds. So if I go back to the other picture here with my slope, it tells me that at, one second here, I've already lost the numbers in my head, at 9.7 pounds. That is the point at which, after 9.7 pounds, is when this slope becomes non-significant. After 18 pounds, it becomes significantly positive. So then the question is, okay, so what is the range of grip strength in the sample? And you can combine that information. So there's a description of what this range is telling you. The slope is going to be significantly negative below 9.7 pounds, non-significant between 9 and 18, and significantly positive after 18. So in chapter 2, I tied that back to the distribution of grip strength in the sample, and it works out that I think for approximately half of the adults in the sample, they would expect a negative age slope, and the other half of the adults in the sample who are above 9 pounds but below 18 would expect a 0 age slope, and there was basically nobody who was above 18. So in this sample, age matters for the lower end of the distribution for grip strength, but not for the upper end. So that's a way to avoid the arbitrariness of estimating slopes for particular values that you're not necessarily interested in the same way that you would be if they were groups. So, an advanced topic, but something that I think is helpful to know. Okay. If I go the other way, the grip strength slope, the pattern of moderation by age is that grip strength matters more in older adults. The slope for grip strength, which was positive at age 85, becomes significantly more positive by 0.12 per year of age. And so I can look at this and wonder, all right, at what point does the grip strength slope turn on? It's somewhere between age 80 and age 85. And at what age would it be significantly negative if I kept going backwards in age? And so that's what the other piece of output up above was telling me, is that 70 and 82 are the cutoffs on this analysis, such that the grip strength slope is going to be significantly negative below age 70, non-significant between 70 and 82, and then significantly positive after 82. And so most of the sample then is going to have a positive grip strength slope as a result. That just becomes stronger in older people. So this is called regions of significance. I just want to put a pin in it in your heads that if you ever need to do a quantitative analysis of moderators, that this is a useful way of doing so. All right. Questions, thoughts? No questions, no thoughts? Fair enough. I can live with that. Do you want to see what it would look like to do an interaction term example that looks something like this? Or do you want to go home? I say go home, but I mean that sort of like I know you're already at home, but like be done. Sure. Oh, wait. Yeah. You should have given us all the choices first. I didn't know that going home was a choice because, yeah, I picked that one. No, I'm being serious, right? It's 1:20 on the last day of class, and I know we're all tired. So if it's not useful, you can watch the video later, or we can do it now. Because we've covered everything that I had a goal of covering. We can go home? Okay. So let me just tell you what the stuff is about that we didn't do. So the motivation to watch the videos. What if I told you that all of that dummy coding stuff that I had you do, like in homework 4 with the golf examples, and where you had to write an estimate statement to get the predicted group means and all the group mean differences, what if I told you that you could have done that in one line of syntax instead? You could. So there is a way to, I know, how dare I? I did it on purpose though. I did it on purpose because there is a way for categorical predictors to tell the program that it is a categorical predictor and have the program provide you with all group means, group mean differences, and so forth. What it's doing under the hood though is what I wanted you to learn. Because the way that different programs handle that differs across programs, and so you can end up with a different reference group if you fit the model in SAS versus Stata versus R, and it is not necessarily clear what the rest of the results in the model mean as a consequence of that. So Lecture 7 is introducing you to that brand of treating categorical predictors. And example 7 then uses the way that you know how to do it as the first model, and then shows you 2 additional versions of that same model using one of the categorical predictors as such, and then using both of them as such, and showing you how the code would change. So I wanted to show you that because I think that approach is more common in practice once you understand the linear model representation of what's going on. But it's not a place to start because it's a black box. So Professor Morpheus, is that a matrix reference? Is that what that is?
Yeah.
Yeah, I hid the matrix from you because you weren't ready for it yet. But that's what the rest of the stuff is about, is sort of rounding out that idea. So, all right then. Shall we call it a day? Not just a day, but a week and a spring. Before we do call it a day, though, I do want to say sincerely thank you to all of you for keep showing up, for participating, for hanging in there, for not getting mad at me, and for otherwise just being great students. I really hope that I get to see you again in another class someday, but if I don't, no hard feelings, because I know that this isn't for everybody and that we all have our own passions, strengths, and weaknesses. So that's it. Thank you. Have a good summer. Let me know if you ever need anything, okay? Bye for the last time, everybody. Take care of yourselves.